Welcome. My name is Alex Belch. This is my demonstration project for MAE ECE 535, Design of Electromechanical Systems. Today I'll be demonstrating Lorentz's force as it relates to speakers. For my experimental setup, I've built two speakers. Each speaker produces different results, which I will discuss later. The specs for each speaker can be seen here. This setup, I created the wiring diagram you can see on the left, and then the actual setup is on the right. In the background you hear some recorded audio from my speakers. I will refer to speaker 1, the styrofoam cup on the left, and this paper plate on the right as speaker 2. For this demonstration I'll use three sources. Audio from my laptop, a 1.5 volt battery, and a 9 volt battery. From our class notes we see Lorentz's force, Lorenz's law defined. If a charged particle Q moves through both an electric and magnetic field, the total force acting upon it is Lorenz's force. This equation can be stated in words as the force is equal to the cross product of the charge's velocity vector and the magnetic flux density vector plus the electric field vector, all times the charge of the particle defined as Q. This equation can also be described as the force is equal to the current vector through the wire times the cross product of the length of the wire and the magnetic flux density vector. The right-hand rule, knowing the direction of the current in the magnetic field, gives us the direction of the force. By changing the magnetic field or the current, we can change the direction of the force, as seen in the lower figure. First, I will demonstrate the effects of change in voltage on speaker 2, the paper plate. The test is simple. Apply a 1.5 volt and then a 9 volt input to the speaker and watch the effects. Knowing Lorenz's force equation and the voltage equation, that current times the resistance, we expect that the 9 volt battery to have a larger effect as the resistance remain constant in the system. The results are as expected. We see an increased movement from the 9 volt battery. The second demonstration is of the speaker itself. Using my laptop as the audio source, I have connected a 3.5mm cable to a left-right RCA cable. The picture in the top right shows how the cables are attached. Before we listen to the audio played through the speakers, I will make a few quick comments. During playback, I will fade from left to right so that each speaker can be heard. I will start with both, then the right, then the left, and end with both. You will be able to turn up your sound to hear speaker 1, as the coil and cup combo make a very quiet speaker. Even though speaker 2 produces audible sound, it is not as loud as the built-in speaker on my iPhone or laptop. The treble and mid-range sounds come through clearly. The low bass sounds peak the system and a thud is heard during playback. I will discuss these more after the demonstration. You can start to hear the audio now. The next two slides have a few thoughts of and results from this project. Thank you for watching, and I hope you learned something from this demonstration.